coastline of Lougheed Island was videotaped at midday on July 17, 1985. Fog banks and low cloud cover restricted our flying height in most places to less than 50 meters and prohibited coverage along parts of northeastern and most of western Lougheed Island. Our video coverage begins just south of the Pat Bay A-72 drill site on western Lougheed Island and continues in a counterclockwise direction around to the northwest corner of the island near Cape Anito. The small islands lying to the south of Lougheed were not photographed. Lougheed Island, located in the central Queen Elizabeth Islands, is roughly 70 kilometers long and an average of 20 kilometers wide. The island reaches less than 130 meters elevation, and it consists of a central region with gently rolling topography, locally dissected by streams, and a gradual sloping coastal plain. The geology has been mapped as a succession of poorly consolidated marine and non-marine sandstones and shales of Cretaceous age. Overlying superficial sediments consist of weathered bedrock at higher elevations and a complex of glacial marine, and deltaic sediment over the remaining island. Most of Lougheed was submerged by late Pleistocene and early Holocene sea levels and has emerged at least 90 meters since roughly 10,500 years BP. Coastal plan and profile is dominated by prograding river deltas and locally at the northern and southern ends of the island by sea ice push and ice override features. The coastal sediments are poorly reworked and often resemble the weathered products of the underlying bedrock and or adjacent quaternary deposits. The detailed shoreline characteristics were mapped by Woodward Clyde Consultants in 1981 using aerial photographs. In addition to the deltaic shores, 3 generalized coastal types were differentiated on the basis of sediment characteristics and shoreline morphology. They are the near featureless sand-flat shores of southeastern Lougheed, which are associated with large-scale fluvial processes, the wide intertidal mixed sediment shores of western Lougheed Island, and lastly the muddy sandy shores with hummocky relief along southwestern and northern Lougheed. The hummocky topography is produced by sea ice push and active layer detachment slides and flows, which are associated with the geotechnically unstable Christopher Formation shales. With respect to the quaternary history, Hodgson suggests that the glacial radix, drumlin, and esker-like features and thick sequences of glacial marine sediment over till indicate an ice movement from the southeast. The consequent uplift and glacial marine deposits are the result of an ice sheet breaking up over Bathurst Island roughly 10,500 years BP, when floating ice or even an ice shelf may have extended to Lougheed Island. Our video coverage begins just near the Pat Bay drill site. Our flight path continues southward across a headland and into Sky Battle Bay. It then continues around the south end of Lougheed Island, between Stubart Island and Edmund Walker Island, and continues northward past Cape Rondon, across the large embayment on the east side of Lougheed Island, and then continuing farther northward along the shoreline. Okay, we just got out of the fog bank and you can just see the west coast of Lougheed Island. We're just near the Pat Bay drill site. You can see the coastline is fairly low lying. A small island in the foreground there. There's a wide intertidal zone, however we are at high tide, so it's not clearly visible. A beach berm is not well developed. There's some ice push, but in the back shore here you can see quite a few tundra ponds and thermal karst development. occasionally in the foreground of the picture you can see shoals and anchor ice submerged at high tide. The material onshore appears to be fine sand, silt, and clay. We're flying at an elevation of 30 to 50 meters and a speed of 110 knots. This shoreline is typical of what was mapped by Woodward Clyde as wide intertidal coast. There's numerous deltas as well. And as you get near the deltas, you can see that the wide intertidal is even more extensive, and there's quite a few shoals and bars. We've just lost the coast momentarily. There's several intermittent fog banks as we go along. Here again you can see the low nature of the coast. There's not a well-developed beach as such. There's several small constructional features. And we're just coming up on a long peninsula that juts out at the southwest corner of Lougheed. As you cut across it, you can see this wet meadow vegetation, some frost wedges, some thermokarst, and is not well developed like in the other spot. And the shoreline we just went by is sandy with a micro-relief caused by aeolian, littoral, and ice push processes. We're just crossing the small embayment north of Sky Battle Bay. You can see a lot of the ice is multi-year or second-year ice. The dirty nature of the ice indicates this. Just coming up here, you can see some anchor ice. There's a good example right there of ice frozen to the seabed. As we go along here, you can see considerable ice push morphology and ponding of waters in behind the ice push ridges. The gray nature or gray colored material and the light colored material indicate a mixture of sediments caused by ice push. Several rivers empty into this area, and again we still have the wide intertidal zone. There you see some light colored, the discontinuous beach ridges. They're very narrow and low, not well developed, but they are all along this area. Most of the rivers don't have beach ridges built in front of them, so it indicates that there's very little littoral processes. As we come up to the western headland of Sky Battle Bay, we're switching from Hazel Sound Formation sandstones to Christopher Formation shales, and you can see there's some better beach ridges along here. Ice push is also much more severe both along the modern beach and in the interior. There you can see some ice push along here, and it's the first indication that the wave action is strong enough to erode low bluffs and banks in the ice push material. You can see some fast ice along shore. It's 12:45 Central Daylight Time, and we're at latitude 77 degrees, 11.3 minutes north, longitude 105 degrees, 3.6 minutes west. We're just coming up on the major delta that empties, that occurs at the west end of Sky Battle Bay. Here you can see some wider low relief mounds in the backshore, which may be related to older deltaic features or also beach ridge formation. Our visibility is picked up as we go along Sky Battle Bay. The interior relief is increased to 60 to 90 meters. Plateau-like feature. The rivers are more incised. This bay is still pretty much fast ice with a very narrow shore lead. Along the modern beach you can see a light-colored material. This there's a band of ice push. It's dried out silts and clays and has a very irregular morphology. It's very compact and sort of like a concrete texture, very hard. And some of it's been eroded away by waves. And you can see in the backshore some discontinuous light-colored ridges which may indicate an old shoreline. This is an area of Christopher Formation shales, but just on this side of the river you can see there seems to be much more sand. It's possibly coming from the interior. You can see some bedrock exposures. We're traveling down the eastern side of Sky Battle Bay. The backshore relief is still 30 to 60 meters. Several large rivers cut through the backshore, and there's some nearshore bars. The shoreline is intermittently visible, but it's primarily ice pushed and with eroded banks in some cases. Just along here you can also see that there's massive shore ice ridges right at the edge of the shore lead. Most of the shoreline is a fine material. You're still underlain by Christopher Formation shales. Much of this area was submerged, and so there's a fair amount of marine clays and silts in the superficial sediments. Lost sight of the shoreline now. Just coming into view, you can see some very large old multi-year ice blocks in the nearshore grounded, as well as these shore ice ridges. The ridges are grounded and are probably playing a major role in disrupting the nearshore bottom. There's an example there. Most of them appear to be partially melted. There's another one there, and are therefore probably more than 1 year old. There's an example at the top of the screen. Another one, and another one, very massive multi-ridged affair. There's several ridges there. These protect the shoreline from any wave action that does occur later on in the year. The backshore relief is getting lower. It's less than the 30 meters. The shoreline still has a hummocky appearance. Those light-toned areas are ice push. And the continuity of those ridges, plus the fact that the numerous tundra ponds, indicates that ice push processes are probably quite a major agent of shoreline modification along here. You can see several nearshore ridges which are probably ice related. And we're at the southern tip of Lougheed Island. According to the bedrock maps, we should be switching into Hazel Sound Formation sandstones, so there may very well be more sand within the beach sediments. However, there doesn't seem to be any major change yet in the beach morphology. In the distance you can see a quite flat backshore, and we're coming into a large deltaic plain. We're rounding the large delta that lies at the southeast corner of Lougheed Island. Very low relief. In fact, the only erosional features you see are at ice bush ridges. You see dark colored there. In the backshore you can see some features that are a lighter tone and are parallel to the shoreline, which may indicate emergence. These may be old shoreline features. You can also see intermittent low beach berms and ice push ridges in the modern beach and just in the backshore. And also along most of this area is a continuous ice ridge, which indicates that probably the whole ice sheet between Stubert Island just offshore in this delta has moved during the winter, forming this ridge. We're coming into Kanguk Formation shales as we round Lougheed Island. And you can see there's very little relief in the backshore. There's some intermittent vegetation, meadow-like. Still a lot of silts and clays and sands. Dirty ice offshore indicates either fluvial deposition or aeolian. There in the backshore you can see some light-toned features which may either be related to the stream channels or to emerged shoreline features. The dark area coming into view now looks like it's a different kind of vegetation. Hard to tell if it's a bedrock outcrop. Just see landward of these ice ridges you can see some anchor ice or remnant shorefast ice. You can also see some ribbons of berm development or ice push on land as well. We're heading up the east coast of Lougheed Island. Edmund Walker Island lies offshore. This is therefore a fairly protected area. Beach development is not that good. There are, however, some emerged shoreline features. Very low, sandy. There's intermittent ice push and poorly incised streams along here. See, most of the ice appears to be anchored to the bottom. And the backshore relief increases to a ridge. It's about 30 meters relief. Intermittent ice push along here. You see some crater-like features. Some of them are filled with water. They appear to be formed by a combination of ice push and beach progradation or fluvial deposition. Still primarily sand silt clay sediment. See some intermittent erosional features where there's ice push. Here, looking into the interior of Lougheed, you get a better idea of the relief. It's near here where Hodgson mapped an esker-like feature which helped him interpret that the last glacial advance was from the Bathurst Island area, from the southeast direction. This coastline's all been mapped by Woodward Clyde as a sand flat coast. Here's some of these crater-like features near the backshore. Also, aeolian processes appear to be locally important around some of the ice push ridges. There's a crater-like feature. And there's another one, but it isn't filled with water. In the backshore you can see some very wide, low, sandy ridges which appear to be emerged beach ridges. It's a very low, gradual sloping plain here. The thin-colored light bands of sediment appear to be either related to aeolian or beach features, beach berm. You can see the odd erosional feature where there's been ice push, and you can also see some anchor ice offshore in the shore lead occasionally. Ridge development in front of some of these deltas and these little offshore berms are probably related to ice push processes and a modification by small waves. Here you can see some aeolian action locally important in the backshore, and much of the area along here shows a deflation surface. See low ice ridges all along the shore lead. Beach ridge development along here is somewhat better. Looking this small embayment, you can see continuous sand beach. Multi-year ice offshore. It's fairly dirty, indicating aeolian or fluvial deposition. And inland you can see a very large emerged beach or fluvial feature. There's some dirty ice there in the foreground. May very well be a multi-year ice. Shore lead is very well defined along here, and it's 10/10 ice offshore. Rivers are very poorly incised except in the interior where the relief has increased. Just here where there's a slightly larger slope along shore, you can get a snow patch. And coming up on Cape Rondon, it's a sandy shoreline, slight berm development, some anchor ice, and there's one of those craters again that's been formed as the shoreline prograded. Backshore slightly greater relief. May very well be some gravels by the indication of the vegetation on the surface. There's some beach development as we cut across this cape, and some aeolian features by the looks of things, blowouts. This Cape Rondon area was mapped as a fine textured coastline, whereas it was sand flat coastline to either side. Looking north along this portion of the coast, you can see a very irregular modern shoreline with ice push, ridges, ponding, and intermittent deltas. There you can see where rivers just entered into the interior, into a pond that's been formed by the progradation of the coastline. And these dark areas along the shore indicate ice push features. Probably the silts and clays, marine sediments have been pushed up. The hill in the background is approximately 50 meters relief. And here you can see very poorly incised fluvial channels. And very fine, hard to see emerged beach ridges. In this embayment you can see some depositional coastal features. Here's a view looking out to sea of the sea ice conditions. The shore lead's still fairly well defined all along this coast. There's a high proportion of multi-year ice in the near shore. And we're getting some condensation problems on the window right now, so you can't see the shoreline as well. However, along here you can see that the coast is severely impacted by ice. There's some fairly large ice push ridges. The whole backshore is an irregular drainage system because of the ice push ridges. Cutting across a very shallow embayment. However, we can't see the beach as well. The backshore slope is increasing, and you can see that the numerous subparallel streams which empty into the coastal zone are now more incised. We're still marine silts and clays. The dark areas along shore indicate ice push of probably the marine sediments, and you can see a very faint raised beach ridges in the backshore. There's a good example there. We're at the most eastern peninsula on Lougheed Island, and we'll cut across the large bay which lies in the central eastern side of Lougheed Island. There's some anchor ice as elsewhere along the shore lead. There you can see a discontinuous beach ridge a couple hundred meters inland from the present beach. It appears that the ridges that do show up are those that have been affected by ice push. We're just looking into the large bay that we've decided to cross due to time constraints. You can see that most of it is 10/10 ice covered, and a large proportion of it, although not very visible on the screen, is characterized by braided deltas, particularly at the eastern and northern end of the bay. You can see the interior has a slightly greater relief. You're up to around 60 meters, 30 to 60 meters. Most of this area of the bay has been mapped as Hazel Formation sandstones, which extend into the interior of the island. Therefore, the sediments are probably much more sandy than what we've seen previously. We're at approximately 77 degrees, 29 minutes north, 104 degrees, 54 minutes west, and it's 11:58 Central Daylight Time. We're at the northern end of the bay now. There appeared to be a camp just back there, farther inland. The rivers are slightly more incised. The back shore appears to be covered in a vegetation. And we're now entering an area that has been mapped as Christopher Formation shales, which tends to be more unstable geotechnically. There's considerable amount of earth flows and other mass wasting processes that are normally associated with the Christopher Formation shales. This portion of the coast has been mapped as fine textured coast by the Woodward-Clyde scheme, and it's interesting that as in southern Lougheed, as you got into the Christopher Formation shales, you get this very hummocky shore topography. As the shales dry out, they become hard like concrete and give a very irregular morphology to the shore. There's very discontinuous, poor beach development. In many cases, there's very large ice ridges along the shore, and where there's slightly more relief at the shoreline, there tends to be some semi-permanent snow patches and ice foot, which protect the shore from any wave action. We're just getting into some intermittent fog banks here. We're losing sight of the shoreline. You do get a very close-up view of the ice conditions. Here there's slightly more relief right at the shoreline. Again, you can see there's no raised beach development. It's all very hummocky and irregular morphology inland as well as at the shoreline. Very old ice grounded alongshore, and you can see there is some ridging in the shore lead. A nearly continuous snow patch lines these shores. There's some rills cutting across the snow patches, but for all intents and purposes there's no beach. This is the most snow we've seen anywhere on the island. The nearshore ice conditions are also very solid multi-year ice. There's little evidence of any wave action along here. Visibility is still fairly poor, but you can make out quite a bit of ice push morphology along the shoreline and also in the near shore, which has been partially eroded by wave action. It appears the position of this ice push indicates some severe ice ridging in the near shore. And in fact, just coming up here, you can see several massive ice ridges off the deltas. There's one there. Most of these ice ridges are partially ablated, which indicates that they've been there for maybe more than 1 year. Shoreline along here shows some ice up on the land, and a very hummocky, irregular morphology caused by ice push or ice-related processes. You can see numerous small ponds which have been formed by the ice push ridges. The near shore is congested with ice, primarily multi-year ice. And we're just getting into a major fog bank. Our video coverage resumes farther up the northeast side of Lougheed Island. Our coverage continues around the north coast of Lougheed, past Cape Benito, and a few kilometers to the south before our flight was terminated by a major fog bank. There's the coast again. We're just coming up on the northern coast of Lougheed Island, flying at about 30 meters altitude. You can see the backshore relief has increased to 30 to 60 meters. The rivers are more in size. However, the deltas are not as well developed. The beach is a discontinuous low bank or bluff. It's very hummocky with a considerable amount of ice push morphology. The near shore is almost a continuous pressure ridge or near shore ice ridge lining the shoreline. Because it lines the seaward side of the shore lead, it suggests that the water toward the shore is actually very shallow, and that the pressure ridging indicates a break in slope. You can see that some of the ice push ridges on shore have been eroded by small wave action. But there's very little wave-formed features. It's a very hummocky, irregular morphology. Much of the nearshore ice is multi-year, as you can see. And along a lot of the coast, there's ponding between the ice push ridges caused by irregular drainage. The sandy material may be due to underlying geology being more of a sandstone at the northern end of the island. There's a faint trace of ridges up on the backshore slope which may indicate emerged features, but it's hard to make it out. There's some of that ponding in between the ice push ridges and the nearshore ridge probably caused by ice push. Shoreline continues to be hummocky, ice push dominated. However, the backshore slope has decreased. You can see a zone right across the modern beach that's been affected by ice push. The farther up slope, it's not quite as obvious. There are discontinuous ridges at a certain level which may indicate an emerged beach ridge, so you can see a little more continuous beach berm development in places. But we're just coming up on the northern tip of Lougheed Island, and there's some really massive ice piles of multi-year ice in the near shore. Here there's some discontinuous beach berm, but it's very short in length. There's those massive ridges right there, just tremendous. You can see it just off that delta. And crossing over the northern tip here, you can see that the whole beach zone has been interfered with by ice, and you can see the massive ridges offshore. This part of the coast, the backshore relief again is decreased. You have a wider shore lead and less pressure ridging at this particular spot offshore. You get a discontinuous shore bluff. It's still hummocky and ice push dominated. The rivers are still moderately incised and filled with snow. You have intermittent visibility due to fog. However, in places you can see that there's some better waveform features along the beach, as well as the more common ice push morphology. You can see some wave modified ice push ridges. Shore lead is wider in these small embayments. There's some sediment deposited on the ice just offshore. And beginning to see some more anchor ice in the shore lead. And this very low gradient coast appears to have a much wider intertidal zone. There's some anchor ice there. Extends all along shore. Primarily a deltaic coast, silt clay material, some sand. The backshore is meadow-like, and there's some thermokarst features further upslope. There's some of the thermokarst that I mentioned, plus some ponding in the modern beach area. Some relict ice push, indicated by the lighter toned sediment. The coast is much more dominated here again by ice push features onshore and sea ice ridges offshore. Some very massive old ice ridges, probably several years old, are grounded along the shoreline. As we round the northwest tip of Lougheed, we see some very, very massive shore ice piles. The largest we've seen so far. You can see the whole shoreline is affected by ice pressure. These light-toned sediment ridges onshore are relic ice push ridges. You can see very discontinuous drainage or irregular drainage all through the interior. This whole shoreline is probably very frequently affected by ice pressure. There appears to be some wave modification of the ice push ridges. You can see a very low eroded bank, but it's very minimal. The ice all along shore is multi-year. You can see the blue nature of it. Like I said, it's probably existed along the shore for several years. You can see some dirt on the surface. There's some small nearshore sediment ridges. And the ice is impacted right on the shoreline. There's no shore lead to speak of. We're now entering a major fog bank, and we'll probably have to terminate the flight soon. There's some very old relic ice push features in the back shore, and a nearshore, discontinuous nearshore ice push ridge. We're going to have to pull up out of the fog and terminate the flight.